Okay, here's your video for 6.5. So like I told you yesterday, 6.5 is the inverse of 6.4. So in 6.4, I said, hey, look at this rectangle and then tell me what you know about it. Oh, I know the angles are right angles. Or, oh, here's this rhombus, tell me what you know about it. So in 6.5, we're going to be going backwards. We're going to be saying, here's a figure. Can you prove what kind of figure it is? And you're going to say, yeah, all the sides are congruent, therefore it's a rhombus. So we're just, same concepts, we're going backwards. Just like for parallelogram, you had that special condition where if one pair of opposite sides were both parallel and congruent, then you could say it's a parallelogram. You have a special condition for rectangle as well. It says that you only have to prove that one angle, that one angle of a parallelogram is a right angle to prove that it is a rectangle. So you have to prove that it's a parallelogram first, or be given that it's a parallelogram, and then if you are, then all you need to know is one angle is a right angle. And here's, let me move this over here. Here's why that works. Because if you have a parallelogram, then I already know opposite sides are congruent, I already know opposite angles are congruent, and I already know consecutive angles are congruent, because those are all properties of a parallelogram. So since I already have all the properties of a parallelogram to rely on, when I tell you that one angle is a right angle, well, opposite angles are congruent, so the other angle has to be a right angle. Consecutive sides have to be supplementary, so if this is 90, then this has to be 90. Opposite angles are congruent, so this has to be 90. So therefore, all angles are right angles, then it has to be a rectangle. So that's why I only have to prove, as long as I know it's a parallelogram first, I only have to know about one right angle, and then all the other ones will fall into place. So there's your special condition. It doesn't go on your quad chart because it's not a property. It's a condition, but that's the one you got to remember by yourself. So let's put it to use here. So AB is congruent to CD, and BC is congruent to DA. So if the measure of angle ABC is 90, why must ABCD be a rectangle? Okay, so the opposite sides are congruent, therefore we know it's a parallelogram, and then you'll say it just like this: a parallelogram with one right angle, therefore it's a rectangle. Okay, the special condition for a rhombus is this next one. You only have to show that one pair of consecutive sides of a parallelogram are congruent to prove that it's a rhombus. That works the same way as the rectangle one did. That doesn't look like a very good rhombus, but you get what I'm saying. So if we already know it's a parallelogram, we already know that opposite sides are congruent. Well, if I come back and I tell you that two consecutive sides are congruent, no longer do these have two different tick marks. They have the same tick mark. Well, if these two sides are congruent, well, now opposite sides are congruent, so these two sides have to be congruent. So now looky there, all four sides are congruent. So it went from a parallelogram with only opposite sides are congruent to then you could go all the way around. If only you know that one pair of consecutive sides are congruent, that's enough to be able to go all the way around. But remember, for that to work, it has to first be proven that it's a parallelogram. So no matter which way you go, you're working your way down the quad chart. You always have to prove it's a parallelogram. To prove that a quadrilateral is a square, it is sufficient to show the figure is both a rectangle and a rhombus. And remember, when you've proven that it's already a rectangle or a rhombus, you've already included parallelogram in that mix. So you don't have to go all the way, you are going all the way down the list, but you're already including that. So parallelogram and then rectangle and rhombus, and that will take care of square. So you're kind of going parallelogram, rectangle, rhombus, and then that will include square, working your way down the quad chart. All right, determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. So let's mark EF and FG are congruent. EG is perpendicular to FH. So right now I have one pair of consecutive sides are congruent. That's the special condition for a rhombus. And I have the diagonals are perpendicular, which is a property of a rhombus that we learned yesterday. The problem here is that I didn't go all the way down the chart. This is invalid. I never proved that the figure was a parallelogram to begin with. So since I don't have any properties of a parallelogram here, I can't use the special condition of a rhombus, and the properties of a rhombus don't come into effect until you already know that it's a parallelogram. You have to work your way down the chart, or it just doesn't work. All right, y'all pause here and try B, using the same picture, just different given, and we'll see if we match up. Okay, I had to erase A so I could write all over it. So this first given right here, these two, those prove that the diagonals bisect each other, and that's a property of a parallelogram. EG is congruent to FH. That proves that the diagonals are congruent, which is a property of a rectangle. Proving that these two triangles are congruent, I highlighted them in green and purple. Well, if those triangles are congruent, then we could use CP-CTC to prove that FE is congruent to EH. So that's the special condition for a rhombus. It's a parallelogram already, with one pair of consecutive sides being congruent. So that means it's a rhombus. And then I can use the special condition for a square. It follows under both the properties of a rectangle and a rhombus, therefore it fits into a square. So this one is valid. Okay, back to the ones on the graph. So just like you did in 6.2 and 6.3 and 6.4, I would suggest sticking to the diagonals. And this one even tells you use the diagonals just because that's two segments instead of having to use all four sides. Also notice on this one, it is already proven that it's a parallelogram. So I don't have to prove the diagonals bisect each other. I already know that. All that I have to do on this one, for a rectangle, I would want to prove that the diagonals are congruent. For a rhombus, I would want to prove that the diagonals are perpendicular. And then if both of those things happen, then I would already get square just by a bonus. Okay, so I'm going to start with that. I'm going to do a rectangle, and I'm going to prove, or I'm going to check and see if the diagonals are congruent. So here we go. So 1, 2, 3, whoops, 1, 2, I can't count today. 1, 2, 3, 4, 5. That is the square root of 26. And then I can erase and go the other direction. Here's the Here's the diagonal here. 1, 2, 3, 4, 5, and 1 again. So I would say the diagonals are congruent, therefore it's a rectangle. Okay, so now I'm going to prove that they are perpendicular. And again, when you use Pythagorean theorem, you've already got the slope triangle already in there. And I can already kind of see just from doing this several times, I know what's going to happen. So let's go back to the same order we were in. I guess it'd be smarter just to do them both at the same time. So for this one, I can see I'm going down 1 and over 5. And then for this one, oopsies. For this one, I can see that I'm going up 5 and over 1. Those are opposite reciprocal slopes. Therefore, the diagonals are perpendicular, so it's a rhombus. So since it's both a rectangle and a rhombus, then I know that's enough to know that it's a square. Okay, you guys pause here and try B by yourself. Same process, new numbers. Okay, so here's part B. When we did the rectangle, one of the diagonals was 5 by 5, so that is 5 on the square root of 2. The other one, this negative one right here, was 3 by 3, so that's 3 on the square root of 2. So those are not congruent, therefore this is not a rectangle. However, when we did the slopes, up 5 over 5 is a slope of 1, down 3 over 3 is a slope of negative 1. So the diagonals are perpendicular even though they're not congruent, so it is a rhombus. It's not a square, because it doesn't have the properties of both. So it is a rhombus only. And I said rhombus only, but remember we already were told in the problem that it's a parallelogram. So when I mean rhombus only, I just mean not also a rectangle and a square. All right, so that is the end of 6.5. I will see you guys in class tomorrow.